Hello everybody. Today I have a bit of an unplanned video. This was a failure analysis on this unit here, which is a PIR module that I have removed from a outside light that I replaced at work today. This light was replaced because this module is dead. However, when I went and looked at it, it had a rather interesting failure mode that I have not seen before, so I thought we would have a look at it together on the channel. What I have done is I have mocked up basically what was inside the light. I removed this from the huge light fixture because it wouldn't fit on the bench properly, but we have the module, we have the supply coming in from the quick connect, a permanent live going into the module, the neutral connection going to both the module and through this flex into the bulb, and then the switch line coming out the module into this connector block and into the line feeding the light bulb. This is an incandescent light bulb. This is the light bulb that was in the light I removed. I think this failure mode would only work with an incandescent bulb. I'm pretty sure if I put an LED bulb into this it would behave very differently. So I want to leave it like this so you could see how I did when I first came across this. So I'm going to turn this on, and you can see this light bulb is strobing. When it was doing it in the situ in the property, it was strobing much more dimly than that, but it was indeed still strobing. And I have not seen that before. Usually the sensors like this will either fail in one of two states. They will either fail catastrophically on, so the light bulb will be on permanently, or they will fail off, so the light bulb does not come on at all. This one has failed in a sort of semi-on, semi-off state. I think the triac inside has probably shorted or broken down somewhat and is allowing current to flow when it shouldn't. But yeah, I have not seen a failure model like this before on one of these modules. I'd be interested to see if anyone else has. I am going to dismantle this a bit so that we can have a look inside this module and see what there is, but I just wanted to show you what happens when I turn it on first. For the avoidance of all doubt, actually, I thought I should just show you, this is the bulb just directly connected to the quick test. When I power it, it comes on, as you'd expect, doesn't strobe, doesn't do anything. The only reason I'm doing that is because for some reason, I'm not entirely sure what they were thinking. I think that the person who said this thought that the bulb in this was an LED because they do often fail in that mode, but the manager of the property where this light was thought that the bulb had failed and they just needed the bulb changed. As I say, that an incandescent bulb like this would not fail in a moderate strobe. However, an LED bulb could, so I'm guessing they made a bad assumption about what the bulb in the fitting actually was. But yes, with that out of the way, I'm going to get on with the teardown. So this little module here, I'm going to zoom in a bit because it's now smaller. On the back, it is Micromark, apparently. Micromark quality, that's guaranteed. 230 volts AC, it is maximum of 100 watts output, patent numbers, patent pending, batch number, blah blah blah. There is not much of interest on here. This looks, poking you the wires, this looks to me like, oh, that's interesting, there's a crack here. Wonder if water's got into it. There was some signs of water ingress inside the light itself. This looks like it has been ultrasonically welded, so I need to get a knife to cut this open. 1 second. Knife. I'm going to just see if I can split the lid off of this. There we go. Might be clipped on actually rather than welded, I think. If we'll oh no, I think it is. Yeah, I think it might be clipped actually. Although this bit here, there's, I don't know if you can make it out, but there's sort of a stringy Move this mic down a bit, see if you can, but they're sort of a stringy stuff, so it might actually be glue rather than welding. And there we go. So we have a bit of plastic. I'm not sure entirely what that's for, because the case on this is obviously plastic, so there's nothing really to stop it shorting on. That is a big capacitor, but I have already shorted the leads out on this. I don't think it's going to zap me. We have on the inside of this, you can see the sort of Fresnel, I think Fresnel lens is what it's called, but the lens on the inside of this to make it work as a PIR. There is a sticker here, 08-11-11, so that might be 2008 or 2011, I'm guessing, but either way this is obviously not exactly in its first flush of youth. I mean, the fact it has an incandescent bulb in it should be all that you need to know that it's not a brand new fitting. There is another bit of this plastic. We have conformal coat on the board as well. That's going to make it fun to reverse engineer. There is a chip which I can't make the markings out on at the moment. Oh, that's interesting. I was going to say the quality of this looks fairly decent, but the soldering on here is absolutely shite. I'll take a closer up picture, but these pins here are barely soldered at all. So that might be why it's... I'm trying to think what could be causing that sort of failure. My initial guess would be it might be the capacitive droppers failed. Maybe. But again, I can't think why that would cause something like that to happen. Maybe the triac's gone bad, so we'll test that too. Can't think what else it could be. There's a little PIR module. I'm assuming that's probably the diode, photodiode to tell when it is dark. There is no adjustment on this, actually. There's no adjustment potentiometers at all. I'm going to take a second to reverse engineer, see if I can maybe clean this conformal coat off and read the number on that chip, and maybe take some closer up pictures, and I'll be back with you in a second. So some investigation has been done. I did look up out of curiosity the patent number which is provided on the lid of the box. It seems to pertain to the, I think, this sort of cowling thing over the top of the PIR sensor, and the fact that the lens only covers part of this dome, not all of it. I didn't read the whole thing very carefully, I just sort of skimmed over it, but I think that's what it pertains to rather than this device specifically. I did use some acetone to get the conformal coat off the top of this chip so I could read what it says. It is a HT7601A, which is a pyroelectric infrared detection burglar alarm chip. Which is what the datasheet says. It uses, I'm just reading through the datasheet here, it is a DIP 16 package, which I think 1, 2, 3, 4, 5, 6, 7, 8, yeah, that works. Anti-theft monitoring, detecting humans with infrared signals, chip integrates, blah 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 blah. Yeah, basically it's a fairly standard infrared chip. It says it's specifically designed for close monitoring of only 1 to 2 meters rather than, so it can be extended to 10 meters using an appropriate lens. And it does in fact have a schematic which I'll take a screenshot of, and I will stick that up on the screen now for you to have a look at if you are interested in it. I don't know if that schematic matches what this is. I've not checked, but it probably does. In terms of failure mode on this, I have been messing about with it. This capacitor seems good, as best as I can tell. Everything else looks fine. This triac, which as I thought, has gone low resistance. So if I get my meter and we set it to ohms, when I measure between the two outer pins here, like that, we get 477-ish ohms. I don't think, I'm just looking if there's I don't think that is a resistor across it, so I'm willing to bet it's probably that this has died. When I look in the schematic, it shows a 56k resistor across it, which that is not. So yeah, I think this triac has died, and what is probably happening is the triac is avalanching. So shorting out, the light comes on, and then for whatever reason, probably the triac gets hot. It will then stop avalanching, cut off the supply, work properly, and then it'll short and basically goes into an oscillation of getting hot and not getting hot, I'm assuming. Anyway, yeah, I don't think there's all that much more to say. As I said, the patent is interesting. It's a strange design of a PIR sensor. I've not seen one that includes this sort of metallic thing over the top before. I'll just quickly explain how these PIR sensors work, because they're quite interesting, and I think this video is going to be quite short, so 1 second I'll explain quickly how these work, and then I'll go on to a quick summary of this, and I think we'll be done, so 1 moment. So the way that these work, I've got something under my paper, the way these work is fairly simple. The secret is all in that Fresnel lens I was talking about at the start. What you have is I'm going to do a norm one, not the slightly unusual way this works. It is the same principle, but different in a way that I don't really understand. So I had a quick read through the patent, and I'm not really sure what the purpose of these is. I think it has something to do with limiting the range of where it can see, so it only looks down at the floor and not up at the sky, but I'm not really sure. Anyway, you normally have a little sensor module here, and then in front of it you have the sort of stereotypical golf ball lens, which has lots of little lenses all the way around it, like this. And what normally will happen is when there is nothing there, the background noise just sort of goes in, the sensor will register it as background. When you have a person or an animal or whatever stands in front of it here, they emit infrared radiation as the heat coming off of their body. The infrared radiation comes through out of them and it will hit onto the sensor here, which focuses it all into dots. So the sensor, instead of seeing a person, it just sees a dot. If you move inside this sensor, there are two so-called paraelectric detectors inside the sensor that are next to each other. As you move, the dot that you are creating will move as well. So when there's background, there's nothing there. This it sees as no movement. When a dot appears, say here, it will suddenly see a difference between these two sensors, and it goes, oh, something's moved. And that differential between the two sensors is what tells it that there is something moving in front of it. This dot will then move across and go onto this one, and again there'll be no dot here and a dot here. It sees differential. If you stop moving, the dot is no longer moving, it won't see that differential anymore, so it will then go back to, okay, there's no differential, there's no change, there's nothing moving in front of me. That is the pitfall of PIR detectors, and one of the reasons why there are now alternatives that are more common for certain applications. Because if, for example, you take an office situation where you have a person sitting in an office working their computer, you want to automate the lighting in that office to save energy. If you put a PIR sensor in, it will see that person walk into the office and turn the light on. They then sit down at their computer and are working away, and after 2 minutes, 5 minutes, whatever you set the delay at, it doesn't see them moving because they're sitting still typing at their computer and goes, okay, there's no one here anymore, and turns the lights off. So you have to wave around like a lunatic to get it to turn them back on again. There are a few approaches to solve that problem. There are certain sensors like microwave Doppler detectors which rely on the Doppler effect, which is sort of, if you imagine a police car going past you, you hear the pitch of the siren go up and down as it moves past you. It uses that same effect but with microwaves to detect movement, and they can detect very, very tiny movement, so like you breathing or typing, that it can detect as a movement. The issue with them is that they see through walls. So if you have lots of office cubicles next to each other, it will see through all of them, and if there's a person here, even though they're 3 rooms down the hall, the detector will still go off. So they're not ideal. The other approach, which is much newer and a bit 1984 type AI overlords, but is to have a camera in the corner watching the room and an AI on that camera looking for people, and when it sees a person it will turn the lights on, when that person leaves it will turn them off. That is foolproof. It will only work when there is a person in the room. It will not trigger when there is nobody in the room. It can't see through walls. It won't go off when the person isn't moving. But as I say, it does make people a bit uncomfortable having an AI watching them doing their job. I don't know, let me know in the comments, what would you say to that if your company put an AI-powered camera in your office to monitor you as you're working and save their electricity bill? But anyway, that is the basic principle of how these work. There is not much more to say about this, honestly. It's a chip following a fairly standard schematic. Little triac has failed, as I had suspected. The capacitive dropper power supplies in these are also fairly prone to failure. The capacitors here, these class X ones, usually fail short, and when they fail short they basically blow the entire module and destroy it, so they are not repairable usually. Anyway, thank you very much for watching. As usual, any comments, suggestions, so on, put them in the comments below, and I will see you in the next video. Goodbye.